Hello everyone and welcome to our next video. This video and all the content of course is in this repo. I recommend going and have a look and follow me if you wish. We've also have, as shown here in the wiki, a few videos on YouTube. First one was starting up a SageMaker instance. They did a bunch of data processing, and then we took that data and tried to generate an LSTM to kind of generate our strong signal for the reinforcement learning algorithm. However, at the end of this video, we kind of concluded that the signal was pretty weak. So this video is going back and basically repeating the data processing, but this time doing some technical and fundamental analysis on it. So in the next video, we're going to be doing all about AWS. So this time I thought I would do the local execution just to kind of show everyone how that works. So if you're on AWS, you obviously want to be there if you're trying to take advantage of all the computing environment. But if you're doing something just playing with the data, sometimes it's easier just to be here. So I've already cloned it. If you needed to clone it, you just do this one command, git clone, and then set up an environment. I've already got my environment set up, so all I need to do is activate it. And once it's activated, you just have to launch your Jupyter Notebook. So when I do all my development, I actually do my development here inside of PyCharm. It's a much nicer development environment. But when you're putting together a story, I find that Jupyter is much better. Last time we looked at the data preparation notebook, and this time we're doing a new data preparation, but now it has no memory since we're not using the LSTM. And so while we're chatting, I'm just going to run all this just to show that it is a functioning notebook. The first part is going to be exact same as the last time. We grabbed the volume or the stock data from online from an API. The only difference now is that we're also grabbing the volume, and we'll be using that to generate a couple extra signals. Okay, and it is just processing, cleaning, and everything up. And there's the volume data, the daily trading volume. The additional part we're going to do now is we're going to be doing some technical and some fundamental analysis. So the first technical analysis that we'll be doing is just a simple 20-day moving average. It is very simple. It's literally a one-liner in Pandas to calculate. But we're going to compress it a little bit further. And in particular, one strategy, or a pretty common strategy, is to look at that moving average and where the price crosses the moving average. That's either a buy or sell signal. So this little bit of code goes in there and detects that. One thing you'll note is that, of course, the signal for this one is sell because the price was above and then it dropped across. Of course, the cross happens between trading days. That's why it kind of looks like there's a lag. So the cross is here between the day, but of course, you don't know until the end of the day what that change was. And so that's why there's a little bit of time delay. So here you had a sell signal. Here it's a buy where it's starting to come up and it crosses over. So we've really compressed this data. And so it makes a lot of processing before we feed that into the machine learning algorithm. We also went back and did a 100-day moving average. So we have 20, now we have 100, but all that gets compressed really, really tightly. Now notice that the machine learning algorithm doesn't have to buy or sell here, and it doesn't know that it's a buy and sell. It just sees these signals as either a +1 or a -1. The other one we're looking at is this MACD. It's a trend following momentum indicator. Pretty straightforward actually. All you're doing is taking the exponential moving average of a 12-day and a 6-day, and you do the difference between them, and that's that MACD signal here. And then we go back and do another exponential moving average on top of that signal, but now at a 9-day window, and this is kind of this signal. And similar as before, we look at the crosses, and we see where the two cross each other. And then again, we have buy and sell signals, and then that's a lot of data now compressed down and passed into the machine learning algorithm. The next one we're doing is the RSI, the Relative Strength Index. It's a momentum oscillator. And here what we're doing is literally looking at how the prices change day to day. That's what this little diff is. And then we look at all the upward movements and the downward movements. And we take the average and a rolling mean, a 14-day rolling average. And we take the ratio of the two. Now, normally this indicator is between 0 and 100, and a trader may have an upper limit and a lower limit that they're trading on. But those limits are kind of arbitrary. So instead of kind of embedding something in that's arbitrary, we're just going to feed it the RSI signal itself. But again, we need to normalize it. So instead of going from 0 to 100, we're going to go from -1 to 1. Because again, when you're feeding stuff into your machine learning model, it's nice to have it normalized around 0, between -1 and 1, or 0 to 1, that sort of thing. and it should be stationary as you go forward. So it's always in that range. And here's basically what we've done. You can kind of see the indicators for the 10 stocks that we have downloaded. And you see the plot. Here we can see the price data is moving up constantly, and that of course results in a nice high RSI. And here we have a drop, and of course the drop generates a negative RSI indicator. And the volume itself, the volume is a very non-stationary signal. Of course, it keeps going up, or not always going up, but it's a very large number, can go up and go down, and certainly change over time. And they're very different between stock to stock. So we want to normalize that and make it a stationary signal. And to do that, we first generate a 20-day moving average on the volume, and then we normalize by that. However, even when we do that, the number is very erratic. Of course, it goes up, very large ups and downs. So we're going to take a logarithmic of that and then clip it. So basically, you can go from -1 to 1, which is a large range on a log scale. But still, it's enough signal. So anything that's above, a log of 1, it's such a large signal that we're not going to worry about that. It's just a large signal. So here it's normalized. Again, you can see the raw data is in blue. The moving average is in, I guess, orange. And then the red would be that normalized, which again, between -1 and 1. We'll also try to encode some time of year. There is certainly in many ways you can do the time of year. The big thing that we want to try to think about is, is it continuous? Is it ordinal, right, or nominal? It doesn't matter whether one month comes after the other, and is there any big discontinuity? So we actually looked at it and thought that it's probably, it's discontinuous, it's a categorical data, so we're just going to consider it to be nominal or non-ordered, which is a one-hot encoding. And the other thing with one-hot encoding, 12 months, but you only need 11 signals. Of course, if they're all 0, then it's January, and all the others will be indicated. 1 here is a December, and and these are all Decembers, and so the Januaries are all 0s. That's why it shows up here like that. So now we get into some fundamental signals. I think this is probably an area where we sort of going to be very creative. Our major limitation is actually just getting the data. If you want to go back 12 years to get all this data for your stocks in your portfolio. There are APIs that you can get that. However, they're usually insanely priced. So I had to kind of go in and get it directly, which is a little bit time consuming. So the first one we looked at was market capitalization. And for that one, we already have the price. So all we really need is the shares outstanding. So we went and got all that data. The other thing that we want to do, and here's kind of your capitalization, is we want to keep it normalized. And this is another one, it's non-stationary, it grows over time. And then we want to kind of keep it in that -1 to 1 range. So what we're doing is at every single time step, we're going to normalize by all of the capitalization in our portfolio. So the largest one will be a 1, and the smallest one will be a -1. And as we go through time, you can see the basic relative positions change over time, but that's always between -1 and 1. That's important as well as you go forward and you get new data. You can never normalize looking backwards in time, the largest over the last 12 years, because as you go forward, you all of a sudden will go greater than 1 or possibly less than -1. Similar with the price to earnings ratio, we had basically everything we needed besides the net income. So we just had to go and get all that net income. And then we do the exact same sort of a normalization here horizontally across the data sets between -1 and 1. So with all that done, we just had to pack up for training, which was pretty simple. The main thing we had to do was worry about that, the estimated 100-day signal. So the first, 99 values were NANDs. So we want to clip that off. So we go in here and find the first one that's not a NAND. And then when we come to the price data, we kind of cut it there as well, but we add an additional day. So when you look at the number of values in the pricing versus the signals, so the signals is 2,922, whereas it's 23 in the pricing. And the reason for that is the signals, when we go into that machine learning, the signals define the state of the environment, whereas the prices are going to be used to calculate a reward, right? So does your portfolio go up or down? And so to know what your reward is for today, you need to know the previous days to get that delta. So that's why there's an additional value there in the pricing. And the last thing I always do, it's always a good sanity check, is I just go through and print it. There's actually 71 signals packed up all together. This one is just that the moving average signals, which is either a -1 for sell or a +1. And of course, again, the machine learning model doesn't know that it's buy and sell. It just sees the signal going back and forth. This is a 12-year. That's why it looks so dense. Some of them don't have as many signals as you go forward. And they're all here. So I'm not going to go through them all, but you can see everything's nice and normalized between -1 and 1. Some of them look a little more interesting. The day of the month, of course, these are just the hot encodings. And then some of them you see kind of flatlined. These are the price to earnings ratio. So this has obviously had the highest PE ratio out of the group here for a while. We've seen some pretty strong movements. This one almost went from the biggest to the lowest over time. So that's all the signals. We pack it all up, put it into a CSV. On the next video, we're going to go into AWS, and we'll clone the repo on AWS. So we have all this data now, because we can clone this, and really why I use, many reasons why I use GitHub. The nice thing is that it's an easy way to move the data around. It also, as you're doing your development, every time you kind of move it from place to place, it stores that in GitHub. So you have that time history. So if you need to go back and roll anything back, you did some mistakes, you have all your historical changes there and explanations of why you did it, all online and available both locally and at AWS. So with that, we will see you in the next video. We will try to create a reinforcement learning algorithm based on these signals and price data. See you soon.